Here we're going to look at the geometric relationship among the tangential component of acceleration, the normal component of acceleration, and the magnitude of the acceleration. So a function here, r of t, this value will be r of 1, and I want to construct the unit tangent at 1 and the unit normal at 1. And then I want to draw in the acceleration. So we know we have to decompose the acceleration into some multiple of t plus some multiple of n. What will that look like? So let's extend t out. Let's extend n out until we see how far it goes. So this will be this version. And this will be that version. So if I add these two vectors together, that will go ahead and give me the vector a of 1. So this vector we will copy over to this side so that we can see it. So it goes about here and then comes here. So again, this is the vector a sub t times t of 1. And this is the vector a sub n times n of 1. Now their lengths, how long is that vector? This vector is a sub t long, and this one is a sub n long. So again, over on this side, this would be a sub n, and this would be a sub t in terms of length. So do you see the Pythagorean theorem here? If this length is a sub t, and that length is a sub n, and that length is a, and these are right angles, Pythagoras tells us then that a sub t squared plus a sub n squared has to be the magnitude of a squared. Now, a sub t could be positive or negative, but a sub n has got to be positive. So we know that's going to be the case. So the acceleration vector is either pointing this way or this way. It's always pointing on the concave side of the curve. More often than not, it's between t and n, but a sub t could be negative, but a sub n has got to be positive. Now how are we going to use this? How are we going to use this to help us discover something? Well, you may recall from earlier work that finding n of t or n of 1 is very challenging. Now, in 2 dimensions, it's relatively easy, but in 3 dimensions, it's pretty hard. So what's the process that we would use to get that n of t? How can we think about this? Well, let's kind of work through a problem here. If I have r of t is 2t squared 3t to the negative 1, or 3 over t. So this is a vector valued function. Can I find the velocity vector? What is r prime of t? It's going to be 4t and negative 3t to the negative 2, which then tells me that the velocity at 1 is 4 negative 3. And the magnitude of the velocity at 1 is just 5. So we know that t of 1 is velocity over speed. So it's 4/5 negative 3/5. So we get that for t of 1. But how about acceleration? So the second derivative, r double prime of t, would be 4 and then 6t to the negative 3. In that case, then the acceleration at 1 would simply be 4/6. Now, from this, we can certainly get a sub t. We recall that a sub t is a dot t. So at t equals 1, what are we going to have? A sub t is going to equal a of 1, 4 comma 6, dot t of 1, dot 4, 5, comma negative 3/5, which will give me 16/5 minus 18/5, which is negative 2/5. Well, that's good. That's good. Now, how about the magnitude of A? It's the square root of 16, 4 squared plus 36, 52. That's root 52. So we know A sub t, we know t of 1, we know A of 1. Can we get A sub n? So here's where we use that Pythagorean thing that we just showed in the previous page. A sub t squared plus A sub n squared is magnitude of A squared. A sub n has got to be positive. So let's write that down. A sub t squared plus A sub n squared has got to be magnitude of A squared. A sub n is positive. A sub t squared, so negative 2/5 squared plus A sub n squared is the magnitude of A squared root 52 squared. So 4/25 plus A sub n squared equals 52. Subtracting 4/25 from both sides. A sub n squared is 1296 over 25. Taking the square root of both sides now, A sub n is 36 over 5. And again, we want to use all of this information to find what n of 1 is. That's our goal, and we know we can check it relatively easy. We have our shortcut method for finding n, if you already know t, in terms of switching the order and changing one of the signs. And just make sure that it's pointing in the concave side of that thing. So let's collect all the information that we know now and determine what n of 1 is. Here's the information that we need. So what do we remember? What's our idea? A of 1 will be A sub t times t of 1 plus A sub n times n of 1. And our goal is to find n of 1, which in 3 space is very challenging. So my A of 1 here is 4, 6. A sub t, negative 2, 5. Times t of 1, 4/5, negative 3/5. Plus an, which is 36/5. Times n of 1. What is that going to give me? 4/6 equals negative 8/5, 6/5, excuse me, negative 8/25, 6/25 plus 36/5 and 1. Let's go ahead and do the arithmetic here. So that'll be 4 plus 8/25, 6 minus 6/25 equals 36/5 and 1. So what is that? We get 4.32. Decimals are just a little easier than the giant fractions, and 5.76 equals 36/5 and 1. So all I've got to do is multiply both sides by 5/36. So 5/36 times 4.32, 5.76 equals n1. Now what does that become? That becomes 3/5, 4/5. Is that what we expected to get with our usual shortcut? So let's look up here for t of 1. T of 1 is 4/5, negative 3/5. The shortcut method is to let x become y become x, and switch one of the signs. So what do we have here? Y becomes x, negative 3/5 here, 4/5, switch one of the signs. I could either switch negative 3/5 to make it positive or 4/5 to make it negative, depending on which way it's bending. But you'll notice our answer here certainly seems reasonable. Change the first one to 3/5, and we have that. So how do we remind ourselves of this process? What did we do here? What was our shortcut method using the geometric relationship amongst these various factors? So what did we need to know? So the first issue, of course, was that A of t is A sub t times T of t plus A sub n times N of t. Now, how do we get A sub t? A sub t is A of t dot T of t. Then how do I get A sub n? I use the Pythagorean theorem that A sub t squared plus A sub n squared is the magnitude of A squared. So once I have that, once I have A sub t, I have T of t using our usual definition, right? What is T of t? Velocity divided by speed. So I have A sub t from this. I have T sub t from this. I have A sub n from this. And I can use that to find N of t. That's going to be our goal. So doing all of our substitutions there and doing some algebra, we can evaluate the unit normal vector with a little bit less work than we normally do, especially for functions in 3 space.